Sensitivity analysis. In linear programming, getting the solution is the first step. Any manager would like to know how sensitive the solution is to changes in the input parameters and certain assumptions. Sensitivity analysis is also called what-if analysis. What happens to the solution if some parameters change? So let us interpret the sensitivity analysis of the output given by solver for this illustration. First of all, let us address how the sensitivity analysis is done on solver. Let us go back to the initial part where I put the trial values. Once again run solver. In other words, back to the original problem formulation and then invoke solver now. When I click solve, I get a solution, I get an output result. Solver found a solution, all constraints and optimality conditions are satisfied. Then the reports part, it says answer sensitivity. So let me just show you here how we can do that part. Let us click sensitivity. Answer, we are already seeing it on the screen. So let us click sensitivity and click OK. Then the computer gives the sensitivity analysis in this screen. How many units of product 1 to be produced, product 2 to be produced, the final solution. And this part gives you some technical terms like reduced cost, which are not needed here, but let me explain what is the meaning of the reduced cost. Reduced cost, in case linear programming has to encounter difficulty in finding the solution, it may give a zero solution to a product. So, what changes are required in the objective function coefficient so that in my final simplex solution, I do not have a negative value as optimality. Otherwise, the computer will say this is not worth producing. So, for what value or change which I need in the objective function coefficients, so that I have in the final simplex output a solution which is non-negative and a positive solution, not zero, but a solution which is positive. In this case, both are satisfied because you have final value 4 and 3.33. Therefore, my reduced costs are 0. It does not give me any negative reduced cost. Let us now look at the bottom part here. This bottom part gives me the final value shadow price. Constraints on the right hand side, allowable increase, allowable decrease. So let me go back. I have captured this in the PowerPoint slide and then we illustrate this. It says, let me look at sales product 1. Sales for product 1. Final value is 4. Shadow price is 1. What is this shadow price? The shadow price is nothing but, it says, if I increase the right hand side value of the constraint by one more unit, what is the change in the profit? Does it increase or decrease? Here the shadow price is positive. We are doing profit maximization. So it says, if I increase the sales per product 1 from 4 units to 5 units, my profit will increase from the present level by $1 more. In other words, at the moment our optimum solution is $130. It will become $131 if I can sell. Instead of 4 units, I can go up to 5 units. Similarly, if I decrease by 1 unit from 4 to 3, the profit will decrease from 130 to 129. So you will not like to decrease it. You will have to ask the marketing people whether they can increase the sales by 1 more unit. So this is called opportunity cost or imputed cost, called shadow price. What does it measure? If I increase the sales quantity by 1 more unit, the overall profit which I get, namely $130, will go up by 1 more dollar and it will become $131. So if I increase it by 2 units, it will become $132. To what extent I can increase? It's a matter of judgment and discussion. Now, what is the worth of the raw material availability? Raw material 1, raw material 2. It says here, at the moment the availability of the raw material is 18 kg for raw material 1, 8 kg for raw material 2. When I have solved the problem finally, I notice raw material 2, 8 kg, I have used only 7.33 kg. 0.67 kg is available, surplus. But I cannot use it because that 0.67, I will not be able to produce 1 more unit. The computer has already exhausted this part. Quantity, and therefore it is like giving something to a tailor for a shirt to be tailored by him, and he charges some rupees and all that. You give some 1.5 meters or whatever. He has used only 1.4 meters. The remaining 0.2 meter he cannot get another shirt, so it becomes a waste. Similarly here, this is the best I could do in order to satisfy all the constraints. As far as raw material 1 is concerned, I have used all the 18 kg. So this is the basic understanding we must have. I have used all the 18 kg. Now shadow price for raw material 1 is $7. What does it mean? If I increase the availability of the raw material from 18 to 1 more kg, 19, then the overall profit from 130 will become 137. It will increase by $7. It's a substantial value. So you will have to put somebody to find out whether there is more availability of raw material 1 so that I can get more money. As far as raw material 2 is concerned, anything you do increase, there is no change in the profit. It is 0. In other words, increasing raw material 2 is not helpful. The profit doesn't change. The shadow price is $0, meaning it will remain. If you increase from 8 to 9, you will still get only $130. Not only the computer gives the shadow prices, it also gives the limits. Allowable increase, it says you can increase it only by 2 units. Allowable increase. So what happens here is from 4 kg it can become 6 kg. That means I can increase the sales quantity from 4 only to 6. I cannot sell more than that because the shadow price of increase in dollar of $1 increase for every 1, I cannot increase the sales beyond this, but I can decrease it. I don't want to decrease it. 1e plus 3, 0. In computer it is e raised to the power 30. Very large number. Allowable decrease. I don't want to decrease it. Similarly, I don't want to decrease raw material 1 availability. But raw material 1 also can be increased by 2 kg. In other words, instead of 18, I can make it 20 kg. If I make it 20 kg, then my profit will increase by $14. Why? Because every 1 kg it will increase by $7. Now the raw material 2, you increase by any quantity, there is no effect on the profit. So let us see, take for example raw material 1 availability, increase it by 2 more kg and find out whether the profit increases by 2 into 7 or $14. Because every 1 kg it increases by $14 for raw material 1. Is the computer correct in saying that? Is solver package correct in saying that? Let us go to sheet 1. In the Excel, the same sheet 1, we have got sensitivity, everything which we have got here. So sheet 1 we go. In the right hand side, I make this 20 kg. What should I get as a profit? 144. 130 plus 7 for every 1 kg increase, 144. Let us run solver again whether I get that. Yes, you got, let me move this, 144 you got. In other words, it says if I increase the raw material by 1 more unit, that means my availability of raw material 1 is 20 kg, my solution, my profit increases by 144, and my final solution is produce 4 units of product 1 and 4 units of product 2. And this is the power of sensitivity analysis. So let me get back here, as usual, the original problem, and the solution is in front of you. So what are the things we are able to learn so far? We can model the problem of linear programming in Excel solver with definition of decision variables, objective function and constraints. We can obtain the solution. Then we can get sensitivity analysis or changes in the solution as a result of changes in the resources of the right hand side. To what extent it can increase or decrease. This is the power. You can also change, instead of profit of 15 and 21, I can just put instead of $15 for product 1, $18 if it is, what is the change in solution? $20, what is the change in solution? Everything you can find out. But the most important thing in LP they look for is the shadow price, which is the increase or decrease in the resources. So the moral of the story, look at the sensitivity analysis here. Sales of product 1 increase by 1 more unit, the profit will increase by $1. That is the shadow price. Raw material constraint increase by 1 more kg, the profit increases by $7. That is the shadow price. Raw material constraint 2, by any amount you increase, there is no change in the profit. This tells a story to the manager. Now, to what extent I can increase sales of product 1? It says maximum 2. Raw material also maximum 2. To what extent I can decrease the sales of product 4? Decrease it here also 10 units. So what I am trying to say, I do not want to decrease, I want to increase. Of course, this shadow price is the sensitivity which we have performed here, the allowable increase and the decrease in the linear programming problem. Okay. So let me just now go back to another aspect. Let us say this product is like a television set or something like a laptop. I cannot get a fractional solution. Computer has given a fractional solution. Does it mean that it is 3 1/3 means the third computer is produced, the fourth computer is only 1/3 produced, and the balance, let's say the display panel is not there, the computer is available, nobody will buy. So there are situations where linear programming mathematically will give a fractional solution, but physically fractional solution in those situations are not meaningful. If it is a continuous production line like the sunlit bond paper, I can produce fraction 3.3 kg, but I cannot produce a computer 3.3 computers. So what I do? I am looking for integer solution. Now when I do round it this 3.13 to 3, I may be making a mistake. You cannot round it in linear programming because it may violate the constraints. I can round 3.33 to either 4 or 3. Which is correct, I do not know. And when the number of decision variables are more, it will be difficult to do it manually. So what I can do here is invoke solver. And in the constraint part, add constraints. I take this reference cell again, the production, and put an option here, integer, int. The moment I put that option and click OK and then solve, I get an integer solution of the linear programming, which is here magnificently 3 units of product 1, 4 units of product 2, $129 is the overall profit. The constraints are satisfied, a magnificent solution in solver. I don't have to tax my mind. If there are so many variables, it may not be possible for us to exhaust all combinations of rounding, and therefore computer uses what is called branch and bound algorithm. Automatically Excel solver takes care. As a manager, I can get an integer solution. So you know now, by now, it takes of course practice how to formulate the linear programming we have done, then how to understand the insights using a graphical method, then how to formulate linear programming for the same illustration in Excel solver, how to obtain the solution in Excel solver, how to perform sensitivity analysis and shadow price in Excel solver, and then how to get integer solution in Excel solver. So this is what we have done so far, and now let us move to the next section, which will be a problem which is a little more involved. How do we formulate it in Excel solver, the linear programming problem, and then obtain the solution as managerial application.